Hello, welcome everyone. I'm Santona Tuli. I'm a principal product manager at Upsolver, and with me is,
Hi, I'm Yoni. I'm the CTO of Upsolver.
and we're gonna talk to you about various streaming concepts made simply. So today, to start us off, we're gonna go with real time. Yoni, what's your take on real time?
So I think that everyone means something different when they say real time. For some people, real time is up to date to the last hour. To some people, real time is up to date to the last minute, or to the last second, or to the last millisecond. Or so. I mean, there's a lot of different. I think depending on how you define it, or like what you consider to be real time for your environment. I mean, it very much matters, like, how achievable it is, how much effort you're going to have to put into it. So I think that's like the first thing. Like, I don't know, what have you seen kind of as far as real time projects?
Yeah, one of the things that someone in finance pointed out to me is we say, in parlance, right, real time, but real time originally the word came from this concept of super actual real time, if that makes sense, transactions, right, in the finance world. So I know there are those. For me, I have worked with sort of particle collision data, which you have to process in real time, but we weren't like doing analyses in real time. So it was more about, okay, the events are being created at the rate that they're going to be created. You have no control over that. And then we have to have the pipeline ready to accept that as that happens. So that's a big one. And then another application I've worked on is in this NLP based product. We had to do online inference. So just the inference portion was online real time in that sense. You would ask something in a chat bot, it'll come through to our prediction microservice, and then we'd have to react to it. So those are the couple that I've done that are real time, real time.
Yeah, I think that's a good point, that like generally when you're talking about real time, you mean request response. So like somebody's asking for something, they want to get a response like in real time, so they want to get the response immediately. But if nobody's waiting for that, then you don't care in the end. Like, there has to be a request that needs to be served. And then you're asking, so how fresh does the data need to be? So like for a bank transaction, maybe I can't have stale data at all. I have to work against, like, I have to be guaranteed that there are no pending transactions before I do mine. Um, but maybe in some cases, even if I'm doing request response, I can live with data that's a little bit not fresh in the response that I get. So if I'm playing a game, or I'm looking at metrics, so maybe I can do a request response, get data that's a minute old, and I mean that's still fine. That still looks like real time from the metrics perspective. So yeah, even in request response, I would say that, so the response has to be in real time, but how old is the data that I'm getting the response that is contained in the response? That's kind of the second. And people say real time, people say near real time, but I think it's almost, you have the same problem, because in near real time also some people mean like a second latency, and some people mean a day latency, and they would consider that to be near real time.
Yeah, definitions, right? The age-old problem.
Yeah, definitely.
So of the two things that you mentioned, right? It seems like there's a distinction between sort of at the engineering level, right? That like responsiveness of the system itself, and then there's the how fresh is our data, which is, to me, like my background is more in data, so is like a data concept. So you can almost like completely separate the two of them.
Yeah, definitely. Like, I can make a request and get a response immediately, and that response will have data that's a day old, and that could be considered real time. Or then I could do the opposite. I can make a request and it'll return in 15 minutes, but I got the latest data, and I could also consider that to be real time. And it's like two completely different use cases and usage patterns. So it's, yeah, definitely.
So what can we do on the data side to like be more up to date and be ready for when the engineering system wants to do immediate responses with the freshest possible data? What can we do to supply that?
Yeah. So, I mean, and again, this is like, in increasing order of complexity of how real time do you actually want it? Like, when you say real time, and I think this is very important, like when you're talking about real time, define what are you actually trying to achieve? Because if you want data that's no later than a day, so you can run a batch process once a day. If you want data that's no later than an hour, then maybe you want a streaming system, maybe you want a batch system that runs once an hour, and it's going to be a bit more of a pain to maintain, but not the end of the world. If you want data that's a minute old or a few minutes old, then, well, you're going to need some kind of streaming system. Like batch systems generally aren't going to work at that latency. If you want data that's a second old, then maybe you need to read directly from the source. And if you want data that's less than a second old, then you probably need some kind of a transactional database, or at least something that's going to make sure that you're not getting any staleness in your data when you query it. So it really depends. And like, as you go down the funnel, things become much more expensive. So like batch systems are cheap and easy, and streaming systems. I mean, again, I'm the CTO of Upsolver, and that's what we do. So obviously, from my perspective, that's cheap and easy as well, like equivalent to batch. And then if you want to go more real time, you start needing to have like OLTP, and those are usually several orders of magnitude more expensive per unit of data.
Very important to know. I didn't know that that it like spiked up quite like that. Very cool. Awesome. Is there anything else on the topic of real time that you want to cover?
Yeah, no, I think just like, reiterate that it's very important to know how real time you need it, because you need to design your infrastructure and design your solution based on that. So, I see people making mistakes in both directions, like saying, well, once a day is enough, and then some business manager comes and is like, wait a minute, but I want the data that's fresher than that, and then they need to re-architect everything. Or in the other direction, it's like, well, okay, let's start with let's try to make it completely real time, and then you make an architecture that would potentially support that with a lot of pain and suffering and cost. And then eventually, like, nobody cares because it's a dashboard, and like, anyways, people aren't like monitoring it live or something like that. So, identifying how much business value you're going to get out of what levels of data latency is very important. And this is regardless of data correctness. So the data should always be correct regardless of how stale it is. But we're talking here specifically about how stale the data is.
Yeah, that makes sense. I saw a friend of mine recently was making this distinction that, online inference isn't equal to streaming. Like those are not the same thing. Like there's some overlap and whatnot, but in general, you shouldn't just think, oh, I need my system to do this, and that's why I need X technology, right? So like that separation of, you should be solving for your use case, for your business, based on what you actually need for it to happen, and then figure out what technology you need. So in the case of like ML, machine learning, online inference, if you need to have like online inference, you need to design that system, and that may or may not require you to have your predictions, for example. They may not need to be like streaming. There might be some request comes in, and you ping an API endpoint that already has the sort of predictions pre-prepared, right? And you sort of grab it and go. So yeah, it all that to say, it all depends on what you're trying to do.
Yeah, absolutely. And like, the more caching layers you can make, obviously, the cheaper it's going to be. I've seen, in fact, many online inference situations where you're interested in historic information about, let's say, the user that made the request but like usually that didn't happen just now. So in fact, while you want your models to be, you're never training your models, or almost never training your models in real time. So anyways, you have a model that was built at best maybe a day ago. And then if your metadata for the users is a few minutes old, then that's not going to affect much. But maybe you want to make sure to enrich your metadata with the current request, because that might contain additional valuable information. So yeah, it very much depends in the end. Like there isn't a hard and fast rule, but definitely, like, you want to be mindful of the cost and the complexity that you're going to end up paying for in man hours or just real cost and money.
Awesome. Okay, well, that's our little short lesson on real time, a concept in streaming, and we'll see you next time.